Hello viewers, in today's session we are going to discuss an important problem from limits, right? And here we have to find the value of this limit, that is limit x tends to infinity, and the function is the square root of x times the square root of x plus 2 minus square root of x minus 3, right? So to solve these kind of limits, what we will do, we'll try to use the method of rationalization, right? So to rationalize this term, that is square root of x plus 2 minus square root of x minus 3, what we will do, we'll assume 1 in the denominator, and will multiply the numerator and denominator by this term with the positive sign, right? So here we have square root of x plus 2, and here we have plus square root of x minus 3, and in the denominator we have square root of x plus 2 plus square root of x minus 3, right? So now we can see that we have a term in the numerator of the form a minus b. This is a and this is b, right? So this is a minus b, and here we have a plus b. So we'll use this identity, that is a minus b times a plus b is equal to a square minus b square. So now we can write this limit as the limit x tends to infinity. We have square root of x, and now we have a square root of x plus 2 square minus the square root of here we have x minus 3 square, right? And in the denominator we have square root of x plus 2 plus square root of x minus 3, right? Now here this square get cancelled with this radical sign, and here 2 also get cancelled with this square root. Then we have limit x tends to infinity. We have square root of x, and here we have x plus 2 minus x minus 3, and here we have the brackets, right? And in the denominator we have square root of x plus 2 plus square root of x minus 3. So now we can simplify this term. So we have limit x tends to infinity. We have square root of x, and here we have x plus 2 minus x plus 3, right? And in the denominator we have square root of x plus 2 plus square root of x minus 3. Now this x and this minus x get cancelled, and here we are left with 3 plus 2 5. So we have limit x tends to infinity, and square root of x times 3 plus 2 5, and here we have square root of x plus 2 plus square root of x minus 3, right? So now what we will do, we'll take this square root of x to the denominator of both these terms, right? So now we can write limit x tends to infinity. We can take this 5 outside the limit notation, and we have 1 over square root of x plus 2 over square root of x, and here we have square root of x minus 3 over square root of x. So now let us combine both these terms x plus 2 and x under the radical sign, that is the square root sign. So we have 5 times limit x tends to infinity, and we have 1 over square root of x plus 2 over x, and here also we can write x minus 3 over x. So we can combine x minus 3 and x under one radical sign, that is the square root sign, and similar is the case with x plus 2 and x, right? So now we can write limit x tends to infinity. We have 1 over square root of 1 plus 2 over x, right? So we can now write x over x plus 2 over x, and x over x get cancelled and we are left with 1. Similarly, here we have x over x, we have 1, then minus 3 over x, right? And now see, here we have x tends to infinity, and here we have 2 over x and 3 over x. So when x tends to infinity, then 1 over x tends to 0, right? So 2 over x also get it tends to 0, and here 3 over x also tends to 0 when x tends to infinity. So this term and this term both are equal to 0. So now we have 5 times 1 over square root of 1 plus 0, and here we have plus square root of 1 minus 0, right? So we have 5 over square root of 1 plus square root of 1, and this is 5 over 1 plus 1, that is 5 over 2, right? So the value of this limit is equal to 5 over 2, which is 2.5. So viewers, this is how by making use of the method of rationalization, we can find out the values of these kind of limits.